And then we also have Mike Ridge, who works for Draper. He's a cybersecurity expert with extensive experience at the corporate, government, research, and startup organizations, and he's currently an embedded systems security architect and group leader for systems engineering, security, and assured systems. So I don't know if he has an acronym for that because it takes up 2 lines on my paper to introduce him. But I think a really smart guy that is currently a technical leader for secure communication projects for the United States Department of Defense. So they've got a really interesting presentation coming up that's going to talk about how unmanned platforms that Mr. Draper is responsible, or that, I'm sorry, Mr. Ridge is responsible for, are using OASIS interoperability standards. So coming from the telecommunications industry, this is completely outside of anything that I have experience with, but it's, I think, going to be a great example of how the OASIS standards are applicable across a range of different industries. So in spite of completely messing up that introduction, I welcome Joe and Mike to the stage.
I don't want it. I have an irrational fear of podiums. And if I have the mic, then I can't hold this. Yeah, I have issues. I have a lot of issues. Oh, you want the mic? Okay. Does it work now? Don't drop the mic. I won't drop the mic. That would be bad. I really appreciated the opening presentation today because I am a scuba diver. I've been scuba diving for 11 years now. I work at the National Security Agency. The reason why I thought I never got shark bit was professional courtesy, but I guess it turns out that the sharks are not particularly aggressive. Okay, let's go ahead and go to the next slide. That's an agenda slide and absolutely nobody cares. Let's go to the next slide. I've been working the IAD for over a decade, so I think it's a legitimate question to ask. How's that information security working for you? Dynamic global threat. That is a recipe for disaster. That's why we see a situation where 3/4 of the attacks occur in minutes, if not seconds, and it takes us weeks, months, and even years to respond. I know I'm not supposed to be playing on your fears, but I'm going to play on your fears. It's more about money. It's not just money. It's people's reputations. It's people's very lifestyles. Mike and I work with the Department of Defense. If we lose information assurance, somebody's 18-year-old kid dies. That's something that I have trouble dealing with. Next slide.
So this is where I work. No, just kidding. We've all seen this before, though. It's always the bane of a systems engineer when they say, oh, we're going to design this new system. Oh, but you've got to be backwards compatible with this, okay? And this evolved naturally over time, the complexity of just trying to figure out all the workarounds that they did to get this going, all the custom interfaces, all the custom code, all the custom drivers. And all of a sudden, I've got to build something, some new functionality, and make it interoperable with this. We absolutely need standards. We need frameworks. We need to be able to do this in order to get security. How many times have you seen in the press, a press release, oh, we did something stupid, but we just didn't quite understand what the system was doing? It happens more than you think. Next slide. So what can go wrong? Well, obviously, this is a real bad thing. It's one thing if you have a bug and it gives you the blue screen of death on a Windows machine. It's a real bad thing, though, when you have your SCADA system go bad and you get cyber-physical systems colliding. The scope and the scale of it are very different. One, I might lose the Word document that I'd been typing on that morning. And yeah, I hate doing that. The other one, people get hurt, equipment gets destroyed. Next slide.
When we stood up the OpenC2 effort, it was essentially what are the standards available for automation or cybersecurity or cyber response. And when I took a look, the closest thing we could find was SNMP. And I thought we really need something a little bit more descriptive and a little bit more robust than sets and traps. So we stood up this effort, the OpenC2 effort. Truth in advertising. We are not going to solve the automation problem. We absolutely are not. We are a part of it. We are going to take a very small piece. We assume that the analytic has been done. We're going to assume that the assured transport is in place. We're going to assume that the key management is in place. Our particular standard is only going to focus on the response portion. The reason why we're going to do that is, number one, it permits us to make a very small, agile, lightweight standard. We absolutely wanted to avoid having a 500-page standard with multiple annexes and multiple volumes. We wanted to keep it small, lightweight, because you and I, we all cut our teeth in layer 3 terrestrial networks with unlimited bandwidth and unlimited processing capability. But as Mike alluded to earlier, we have to move to the Internet of Things with very constrained size, weight, and power constraints, very constrained. We're going to have to look to devices that have very little processing power. I am not saying you don't need information assurance, and I'm not saying you don't need conditional logic and analytics. What I am saying is it's out of the scope for us. If you take a look, all three of those, well, 2 of the 3 are OASIS standards. One is kind of the redhead stepchild, isn't it? Okay, OpenC2 is in the pre-standard stage right now. We're still working it. But we are going to use OASIS standards to enable an environment for unmanned platforms. Next slide.
Cool. Now I'm going to give you a little bit of background on something called Joint Communications Architecture for Unmanned Systems, or JCOS. This was a OSD-funded, Office of Secretary of Defense, DoD-funded effort to try to standardize interfaces around command control of unmanned platforms. We have a couple slides later talking to it, but this whole notion was coming up with an open framework so that these pieces could be reapplied into other systems. So the first thing I said, well, let's see, we'll use SNMP for this because I know it. And then I talked to Joe. Joe's like, Mike, get your head straight here. We need to start talking about suites of systems, and SNMP alone isn't going to cut it. So that's when we started talking back and forth about how we could come up and deliver something for DoD using open standards that would actually be something that they could reapply into the future. Next slide.
Now, when we designed OpenC2, one of the strategies we took is we decoupled the actual action from the target from the actuator. So that was a lot of internal speak. So what I'm saying is the action is what we're trying to do. And I submit to you that that's been stable for 20 years. You do blocks, you issue allows, you do redirects. That's been stable for about 20 years. The targets have been reasonably stable. We're protecting ourselves against the compromised user or the insider threat. We're protecting ourselves against malware. The real excitement or the real dynamics in cyber defense is in fact what we call the actuators, but I'm talking about the cyber defense products. 20 years ago, the virus scanning companies gave you signature files. Today, they're using advanced Bayesian classifiers. That's where the dynamics are. So we decoupled them with the idea being that we don't have to update the spec at a rate of Moore's law. Good on a PowerPoint slide, sounds good in paper. On a layer 3 network, if we issue a deny, a firewall's going to do a block. If we issue a locate, well, the AT&T Corporation delivered a GPS coordinate for I think it was a laptop, maybe it's telephony. an allow, that's just simply a mathematical complement to a deny. But the question becomes, how is that going to manifest itself in a non-traditional layer 3 terrestrial device? How is it going to manifest itself in something such as a UAV or an unattended sensor or a underwater vehicle?
Cool. So what I started doing was putting together a framework where we could set up some experiments. At the top here, I have an environment. We got users. We have a GitHub site for a bunch of code. We take everything, put it into Docker containers, and I set up a network of 100 Raspberry Pis. Okay, so that was the simple physical system that we were doing testing on. And on the bottom here, I started developing systems and solutions that one might need in a distributed or even a central system for making decisions. So in this one here, we were doing statistical analyses, and we were able to do it in a distributed fashion, where each one of these Raspberry Pis might represent a single unmanned platform. Okay? Next slide.
Now, obviously, the Navy was very much focused on their toys, and my computer programmers were really jealous because they got to play with the Raspberry Pis and the UAVs, and my guys were stuck behind desktops, so they weren't happy. But my guys had an important job. We had to create a message fabric to integrate OpenC2 for JCOS. So we explicitly limited our guys. We were saying, you are going to focus on the OpenC2 layer, if you will, and we're not going to give you a lot of information about that actuator, about that UAV, or about that end device. So we actually intentionally constrained them, and they were not happy when they were writing the code. However, they did come up with this framework. This particular framework supports a star topology with HTTPS. It supports a pub/sub environment using MQTT. We're supporting 3 serializations. We used JSON because everybody and their pet dog is using JSON nowadays. But we also support CBOR. We support protobuf. So we have 3 serializations, 2 transport mechanisms, 2 architectures. From our point of view, those dotted lines is just some box. We don't know if it's a UAV or a router. We really didn't know. Next slide.
Thanks. So this is a notional representation of the systems, products, programs that JCOS was intended to support. So you're talking aviation platforms, ground platforms, underwater platforms, and a whole bunch of different pieces there that people owned. But in the end, what we were doing was using OpenC2 to provide situational awareness between the devices and to be able to set up and handle specialized cases. So I'll be getting into the specialized cases next. Next slide, please. So let's pretend that I had a bunch of monopole antennas, a bunch of quadcopters up there. If they're flying around and they started receiving jamming, what is it that I could do about that? Next slide.
Well, I thought this was one. I think this is me.
Yeah, this is me. It's okay.
We could have done a better job.
So
okay.
What we can do about that is start using those monopole antennas to start analyzing signals that are coming towards us, do direction finding on those signals, and start figuring out where the GPS location is of that signal and what it is that we may be able to do about that. So some of the student projects that I were doing were to set up that sort of analyses, be able to do the statistical processing or the distributed processing or even centralized processing.
Go ahead and go back a slide if you would. The use of n-channel arrays, array of monopole antennas, in order to find a line of bearing on a signal of interest is mathematically intense and involves a lot of specialized knowledge. From an OpenC2 perspective, I didn't care. From my perspective, all I said is, well, I could issue a sync and that tells all of those UAVs to fly in a spiral array, in an elected designated router, much like OSPF. And then I could issue a copy. So that is telling all of those quads or all of those UAVs that you store all of the RF energy that you collected for the last 2 or 3 seconds. That's all I had to do. I don't have to understand N-channel, or I don't have to understand the matrix algebra. I didn't have to understand anything. But I got the same strategic effect with 2 very simple actions. Next slide. This one's yours.
Gotcha. Thanks. So what we then are able to do is the mathematical computations in a distributed fashion, be able to provide those signals back to a centralized controller or distributed controller, whatever it is. And if you go back to that picture of all those devices that we were looking to support, all of them could participate. Okay?
Next slide. From an OpenC2 perspective, again, I have not done matrix algebra since I was a junior in college, and I hated it then, and I let those neurons die. From an OpenC2 perspective, the event happened. We pass to the UAVs, and we tell the UAVs, look over the history of the last couple seconds for this signal of interest. If we're in a low jamming environment, we're going to put that data back to the carrier task force, and they'll do the mathematics. If we're in a high noise environment, we're going to do distributed computing, and we're actually going to determine that line of bearing and send it back. Again, the Navy had a very difficult problem, but within OpenC2, we didn't care because we had these high-level actions that mapped to a very specialized use case. Next slide. Okay, Mike and I spent a lot of time on this, and well, actually, Mike and I, we don't really work anymore because we're senior engineers and all the junior engineers actually do the work. But the junior engineers did a heck of a lot of work. They did a very good job of mapping the OpenC2 actions, which were designed for layer 3 terrestrial networks, and mapped them to the RF domain. Case in point, if you're in a layer 3 network, you're not going to, and you want to maintain some security, you want to be anonymous. You're going to avoid ping sweeps, port scans. You're going to avoid that sort of thing. In the RF domain, what are you going to do? You want to deny a radar jammer. So you're going to send out or you want to deny a radar signal. So you're going to send out a radar jammer. If we want to include friends, we're going to give them the transect key. These are the layer 3. In layer 3, we would have issued a deny or an allow. In the RF domain, we're issuing a deny or an allow. We're having an identical strategic effect. Slide.
So this one's me.
Okay.
So what we were doing with our Pi network as well is looking at topologies of networks and what may work best for different kinds of systems. Found some interesting things there. We were agnostic of the serialization. Although the JCOS program may go down a particular serialization path, it's not something that we would have required of them. And the whole idea of this thing was be able to provide a framework that one could build upon as well. What we were doing with the radar systems could then be reapplied for LiDARs, could be reapplied for other sensor types and systems, and you could build this thing and add new features, functions, without having to go back to proprietary code. Next slide.
Can I do this one?
Please.
Okay, thank you.
I have no idea.
Okay. At the risk of sounding melodramatic, we actually had our face-to-face yesterday and the day before yesterday, so this slide was kind of being updated last minute, last night. We're actually in a very good spot, and as I mentioned earlier, in OpenC2, we decoupled the action and the target from the actuator. So when we develop our specifications, we have the language specification captures those actions in the baseline target set, and then we have individual specifications to cover the end devices. So we have 3 of them out now. We have the language specification. That is that overall language description, that language semantics, if you will. We have one actuator profile that is ready for public review, and that's to cover stateless packet filtering. And then we created a transfer spec. As I said at the beginning, we are a part of the solution, not the entire solution. So in the transfer spec, what we're doing is we're focusing on other protocols to fulfill those other needs. The first one that we put out was HTTPS, but we also have MQTT on the horizon. So that was one of the decisions that came out of the 2-day face-to-face yesterday. So the take-home message is I think we're in a very good spot right now. We have a little bit more spit and polish and a little bit more editorial massaging to do, but we are projecting that on October 17th, we will in fact release all 3 of these specs for public review. Next slide.
Cool. JCOS. The DoD plans to take the learnings that they got from us and apply it to a series of platforms. They're still deciding whether to do additional basic research. We've told them, hey, let's start taking this stuff to put in platforms. Let's start giving it a try and build it as the platforms grow. They're worried about something called the technical readiness level. We'll see. I don't know what decision they're going to end up making about basic research on JCOS. But the contracts are starting to move out already, and it's already baked into their roadmap that was released last year for unmanned systems. The real tiny text there is the link on the internet for that. I think they're distributing the slides. You should be able to read it on the next one. Next slide. So what I'm also continuing to do is work with students. So these are some of the organizations that I was working with this past summer. I've got a follow-on work with Northeastern already. We're running a student project there this spring, and I'm pretty sure that I'm going to have something at NYU going by this spring as well, but we'll see. So these. Okay, yeah, that'll give me a hard time now, rightly so. Anyway, these are the organizations. The first one that we signed the deal and we're working with is the Northeastern guys. So I've been doing my end with college students, mentored college students, but college students. That has its own idiosyncrasy sometime, but it actually works out really well. I find they're a bit more creative than I am at my stage in the career. So anyway, next slide, please. I was taking the first bullet on this one, right?
Yep.
Okay, so we are continuing to work with the NSA on the actuator profiles. We're going to continue to refine the list, and as platforms get delivered, we'll probably be right there with actuators for the missions of that platform.
We had a lot of fun working this because it was a brand new use case as opposed to what we're used to working every day. And it was a lot of fun to actually have these scenarios with the UAVs and the underwater vehicles. And then, some of us were immature children. I grew up a year ago, maybe. But, then all of a sudden, the kinetic, and we had a ball. Yeah. We had fun, but it illustrated something very important to us. We can, in fact, take this abstract language and apply it to other use cases. So I have 2 requests of this audience. First, you're all OASIS members. We want comments on that public review. Look at it from your perspective. I've always been proud of the fact that OpenC2 was the second largest TC. We're second only to CTI-TC. But having said that, despite the fact that we are the second largest TC, we are still a very small subset of the people that a very small subset of the cyber industry. So please give us those comments. And second, bring us your use cases. Tell us what actuators you should be looking at. If I was to talk to some of my colleagues at AT&T, they would think it's kind of amusing that I'm worried about swap-constrained environments because they're a telecommunications company, so they got lots of bandwidth. But we need to know those unique use cases that you have that might be swap-constrained, or they might have processing constraints, or they're a cyber-physical system. We need to hear them. And I think at this point we're at the questions, comments, complaints point. Yes. So if you have any questions, comments, I will take them. If you have any complaints, my colleague, Mr. Ridge.
Uh-oh.
Nice suit.
Thank you.
So I noticed you use k-means, and it's certainly a solid methodology. There are alternatives to it, though, that may be setting specific use case specific advantages over k-means. I know it's kind of one of the simple ones. You know, there's nearest neighbors, there are others. Are you looking to try others?
The answer is absolutely.
Yeah.
Truthfully, for that particular student, it was her first real statistics class as well.
Yeah.
So what I was looking for was something that we could at least start. And much of the work was actually around the networking and the distribution of all the processing work.
So you focused on that, and you figured you'd get the statistics overlay later.
Exactly.
Gee, I wonder where you could do that.
Thank you. Mine is a three-part question. One is about the monopole antennas that you mentioned. I think you partly answered that question. My question is about how do you differentiate signals that are of interest from the noise? That was my question. How do you focus on the required target? A related question is, thinking about future, we have a lot of efforts, say for example, in malaria eradication programs, where we use genetically modified mosquitoes, or we would use mechanical mosquitoes that, say for example, MIT is working on, just for example. So how do you differentiate devices like these, which are meant to be good candidates, versus the rogue devices? And the third part of the question is, do you have any implementation guidelines for vendors?
I will take the first and the third. You can have the middle one, because I know nothing about mechanical mosquitoes.
Fair enough.
Okay. What they do, if you want to find a signal of interest, they'll set up an array of monopole antennas. And then once you know what you're looking for, you use the different time of arrival as it hits the array. And then you're just using GPS. It's not rocket science. And then you throw a line of bearing. And then if you have multiple such arrays throughout the world, you can get the actual location. How do you identify the signal of interest? Well, if I was in a different environment, I might go into that. I think here we'll say that we know the transponder signal of the whale that is being.
Right.
Yeah.
On that note, though, in the latest version of Wi-Fi, let's pretend that somebody's microwave isn't fully shielded, and it's throwing out a whole bunch of 2.4 gig frequencies. The latest version of Wi-Fi will just not use those channels. So that might be an effective response in that environment, other than the fact that somebody ought to take that microwave out of the system. So it depends on the environment and what the goal is, okay? And I think I owe the mosquito, I don't have a clue, okay? We can talk. At my company, we've built these dragonflies with little backpacks, and they fly around and you can do stuff. I don't know a whole lot about that. I'm a comms guy, I'm a signals guy. If we could give every one of these mechanical mosquitoes a MAC address, I'll know how to do it. The short of it is I'd need to know a little bit more, and even then I may not be able to answer the question.
think I had the third one, but I'm kind of embarrassed. I forgot the third question.
Yeah, I was going to comment that we might want to take them one at a time.
Yeah. Oh, I know. Okay, the question is there guidance for implementers out there? Okay, sort of. And what we are doing within this TC is we do have a draft, what we call actuator profile writing guide. So the idea being is if you look over this, you know what other documents to look at in order to fill out what you need in the proper procedures and the proper formatting of the abstract schema, ... Those are currently in draft, and our guys are working quite hard to make that happen. I'm going to go backwards a little bit on your mosquito question. What you're talking about is device authentication. And what you're talking about is how does one go about doing robust device authentication for very swap-constrained devices. That's a tough one, okay? And there's a lot of people with 10-pound brains trying to work that problem, and I'm not pretending it's solved yet. And I think we're getting the hook, right? Yeah, we're getting the hook.
All right, thank you, Mike and Joe. So now I'd like to invite the panel to the stage for our next session, which is a panel discussion. So we're missing Efrain. Oh, okay, everyone to the stage, yeah. Okay, so we're mixing this up a little bit, doing a panel discussion on operationalizing automation standards for cheaper, better, faster cybersecurity. So we've got a really great panel that we're gonna talk about this issue. So starting at the end, we have Mike Stair from AT&T. He's a lead member of the technical staff in our chief security office, and he is absolutely innovative, brilliant mind that I've had the pleasure of working with for a while on cloud security and our threat analytics platform. And Mike is going to be able to share a perspective from the user on how OpenC2 helps automate the security lifecycle. Then we have Daniel Riedel, who is the CEO and actual founder of New Context Services, which is a lean security firm. He's got over 20 years of experience in technology and operational infrastructure. And I had the pleasure of getting to talk to him for quite a while the other night at dinner, that he's an extremely innovative, inquisitive person who has some really great experience in building secure, scalable technologies and businesses. So he's gonna be able to provide insight on what OpenC2 means for getting to the left of boom, as Sunil talked about earlier today in the energy and IoT industry. Then we have Phil Royer, who just came in this morning from Orlando, a very late night last night at a user conference. But until a year ago, he worked up the street at Johns Hopkins Applied Physics Lab, and since then he has joined Phantom, which was then recently acquired by Splunk, so it's Splunk Phantom or Phantom Splunk, whichever way that goes. But there he builds automation capabilities to respond to security incidents with a mix of human and machine actions, and he can provide a perspective from a security orchestration vendor on our panel. And then finally we have Efrain Ortiz, who is a director in the office of the CTO at Symantec, and he actually started his digital life on a TRS-80 color computer too in the 80s. Yeah, but since then he's been at Symantec. Lots of since then stuff. So he's going to be able to provide some really great insight as a vendor and share on his experiences with open source tools from the vendor's perspective. So we're going to start with, I think each of our panelists have some slides that they'll share to set up the discussion, and then we are going to open it up for discussion amongst the panel with input from y'all.
All right, thank you. So go to the first slide, please. I'm going to talk from the user perspective, and we really care about automation from end to end. So we have to be concerned with really all the different functions. I'm going to quickly review this really high-level reference architecture that we're using for some of our internal automation efforts. If you were all familiar with the Integrated Adaptive Cyber Defense effort, IACD, out of Johns Hopkins, APL, NSA, and DHS, this probably looks familiar. We've been aligning to the IACD vocabulary and some of their core principles in the work we're doing. So I'm going to work through this, kind of clockwise, because I don't have a laser pointer, and start at the top. But I do want to call out those colored pipes, those lines, kind of connecting everything, and that's representing topics on a message bus. So Joe talked a little about MQTT. It's not an incredibly critical detail. You can use whatever transport you want, but we found that a pub/sub transport works really well for doing this type of automation because you may have multiple subscribers that are applying logic based on whatever their function is. So let's start at the top here, the sensors and actuators. So again, IACD, OpenC2, vocabulary, and these are all the technologies we know and love and we have deployed all over our enterprises, or our perimeter devices, firewalls, proxies, some of your endpoint devices, agents, and if you're doing any migration or adoption of cloud, either public or private, all the different native cloud services, security services. One thing in common is they like to log, and they like to log a lot of things. And that's all the cyber events feeding into that threat analytics over there. And this is what ICD calls your sense making, so taking all that sensing data, applying some analytics, some algorithm to find any malicious or abnormal activity. Along with that sense making and kind of complementary over on the right there is all the sense making services. So these are things like threat intelligence. So we heard about the STIX standard, and I think there's a session later this afternoon that may go into that a little more detail. Just general context enrichment. So things like IP reputation services that you can get additional information on alerts. And then finally, enterprise inventory, which is really paramount if you're doing automation. You need to understand your assets. You need to understand what their business functions are, what their impacts, if you're going to take any automated action against them. So your threat analytics, publishing alerts, and on the bottom there, the COA workflow, that's one of your subscribers. That's the decision-making logic. So that's the business logic that you're going to apply to these alerts to determine what your COA, your course of action, how you're going to respond. Over on the right there, that's our analytic team. We have an amazing team of analysts from our SOC Tier 1 all the way up to our Tier 4 super analysts. And there may be scenarios where you need to have open loop workflows where you need a human to review before there's any action taken, so it's not full closed loop automation. Also reversibility. So this is automation. There's a slight chance you may make a mistake, and there may be some unintended business consequence. You need to be able to back that out or make a change. So again, that business logic, that decision making is going to publish out what our course of action or how we're going to ultimately respond, what actions we're going to take. Case management's important here, so it's also subscribing. You need some way to be able to audit, right, what happened. Because this is automated, we'll maybe open a case when we see some kind of course of action and then auto close, but just some traceability, right, of when something happened and why. And then finally, up in the left there, the response orchestration. This is where you're going to take that actual action, mitigate whatever the issue is. So internally, we have some capabilities we developed that really keeps a universal view of policy, and we're able to audit and also make changes. So here is where finally, I'm getting to it, OpenC2 comes in. So using a standard interface really simplifies, when we have to put out these different policies to the endpoint actuators that are actually enforcing the policies. So this is really just kind of the full loop to bring it all together where we have all these standards working together to simplify. Go ahead, next. This is really high level. I just wanted to drill into one of those workflows. So if we drill into the course of action, so something that Phantom is one of the better known security orchestrators that provide this capability. But this is a simple malware containment example. You get an alert in. Again, we're doing some additional sense making because depending on what function this asset has may determine how we respond. If it's something that's business critical, depending on who owns it, may change how we're going to, ultimately put action in place. This one's open loop, so we, again, make a call out to our analyst team, and they'll ultimately make a decision, are we going to contain this workstation, or are we going to fall through? And again, we're publishing out that course of action for any subscribers that need to keep track. Go ahead again, next please. Oh, Nick. And then just finally, some open source work. So, Joe mentioned that OpenC2 is close to public review, but as of today, there's no native support in any vendor products. So we had to write a bunch of these translation adapters, we call them. So you have OpenC2 coming in, and you translate that to whatever the proprietary API is for that vendor. When we started writing those, we realized it's kind of hard to do that manually, so we wrote some standard libraries to assist with that. That's this OpenC2 Lichen. It's available out on the Oasis GitHub. And then one of my coworkers also wrote a reference implementation if you're using AWS public cloud to be able to manage some of the access control lists or the security group virtual firewalls. And that one is out on the AT&T GitHub. Yeah, so just to summarize, users, again, we're responsible end to end. So, we need to align to standards. It really helps with interoperability and to push forward our internal efforts. Thanks.
Thanks, Mike. So then I think Phil is actually up next.
That's right, yeah. So as Michelle mentioned, I was down in Orlando yesterday. We were in an arena with about 8,000 people for this big presentation with all of our power users that use our Splunk and Phantom products. And these people are, many of them have been on these platforms for years. They're very skilled at writing the most advanced analytics and creating playbooks or workflows like Mike was showing on the Phantom platform. And these are all ways in which you can create content to solve these complex problems. And I think that's kind of what this standardization we're working on is enabling. There's going to be a huge amount of use cases that are not fully covered by OpenC2, which is the standard Joe was just talking about before us. But we want to hit those, want to take those most simple use cases and make them easy, scalable, maintainable, repeatable, and reliable, so that you can have these things always working, and then you can go out and do the more advanced use cases, like whether you have a new way of analyzing malware, or you have a new technique using deception to trick an adversary into looking in the wrong place in your network. These are the kinds of more advanced techniques that currently a lot of our practicing information security professionals simply do not have time to do. So we want to kind of move that needle a little bit to give them a little more resources to go out and do the more advanced use cases by making these simple things very repeatable. So with Phantom, what we're trying to do is we're trying to make it easy for them to use these OpenC2 APIs. And so it should be very simple to block an IP, as Joe was showing, or to shut down a particular device that is causing the problem. It's not the end-all solution, but it's something that needs to be done in some cases very quickly, and it must work, or else you're in a really bad position. So that's the goal with Phantom and OpenC2, and I'm really excited about where things are going. So like Joe just mentioned, the October 17th release. I think I just want to reiterate, he said this, but more eyes on that, the better. And the more contributing members of that, the better, in my opinion. We just showed a bunch of open source libraries. Anyone can go pull those down, experiment with them, add to them preferably, not just look at them, but add some more code there and get these things working for a large number of products so that we can all integrate together.
Good. Thanks, Phil. And then, Daniel, I think you're going to provide some insights for us.
Yeah. Okay. That's your slide. Next slide. Great. Actually, I want to break it down into 3 areas. Passion on why myself and my company got involved with standards, and then how we started applying that in research in the utility environment, and then how it's actually, in some cases, come full circle. So New Context is a small consulting company based out of San Francisco, but we have consultants all throughout the United States and a fair amount in Kansas City. And we care a lot about building technology well and actually using security by design or building, using automation to implement security. And so what we find ourselves doing is helping organizations build, in critical infrastructure, build secure, scalable platforms. And a part of this, and an important part of this, is automation. And so if we can go to the next slide. And because of our passion in automation, we ended up getting in and working with California utilities. There is a project called CES 21, which is a ratepayer funded project. And it was 3 utilities, Pacific Gas and Electric, Southern California Edison, and San Diego Gas and Electric, and in partnership with Idaho National Labs and Lawrence Livermore National Labs, and ourselves. And they knew about our passion for automation, and we were positing 4 years ago, is it possible to do machine-to-machine automated remediation and response in the OT world? Not the IT world, but the OT world. And this was up our alley. We thought this was great, and what they wanted help with is actually building a language around that. And so as we got involved with that organization and involved in the project, you can try and build a language from scratch. I don't recommend that. Or you can go out there and see what can you use. And so that's where we came to Sticks and we came to OpenC2, because these were relatively, they had started. OpenC2 quite hadn't started yet, but Sticks was. And we started working with these and seeing how we could adopt them for describing threats, and then also the course of action, which we just talked about here. And also taught us a lot too. I think Mike and Joe shared a slide earlier with 2 trains going at each other. In the OT world, we don't have a lot of room for mistakes. And this is something that the IT world gets to iterate very quickly on and gets to make mistakes very quickly. But you can't do that when you're going to blow up a transformer. You can't do that if you're going to cause physical damage. And so you have to be very careful as you approach these languages. And so we worked and had several use cases that we worked upon. And we actually, 4 years later, we're actually now seeing our research starting to roll into production. And that's actually really exciting. And we're just starting that now. And there are a lot of tools out there. We have Phantom and Eclectic IQ and Sultra, et cetera. And these tools are good baselines, but we're also looking how we can implement that in the OT environment, and where we are now able to start doing that. And so it's been great to be a part of that research. There's actually some open source tools that I don't have the URL here, but I can share it later on, that are actually being announced as a part of this project for working with threat data, and we're excited that this research project has become that. Next slide, please. The other thing that we've liked, now that we have done this research with OpenC2, we've actually been able to come full circle, because in our day-to-day lives, we also mean day-to-day lives for new context means that while we're working in the utility sector, we're also doing a lot of work in building data infrastructure in the IT sector. We are now taking some of these methodologies and bringing them back, and using some of the open source tools that Mike has put together. We are looking at how we can do very quick command and control with AWS. And for some of those familiar in the cloud environment, there may be a lot of tools out there, such as Puppet and Chef, et cetera. There's no generic tool set out there. And so the fundamental importance about OpenC2 is it's a shared generic standard that everyone can use, can issue a command. And so we're actually seeing that come full circle now back into how we actually manage the cloud with cyber threats and remediation.
Thanks, Daniel. And then we're going to have Efrain wrap it up for us on some thoughts, and we'll open it up for questions after that.
Okay, thank you. So I'm going to go back in time about 2 years. You can leave that one up. I got invited to attend the IACD conference, not knowing what to expect. I was just roped into it. And I fell in love with the concept. I saw my first OpenC2 presentation. And then Wendy Peters, who was working there at the time, asked, why don't you write a proof of concept for Symantec endpoint protection? And I'm not a programmer. I'll say maybe I'm a scripter. But I said, sure, why not? And I took up programming at that point and took it as an opportunity to learn Node.js. So I wrote this proof of concept to connect the Symantec endpoint protection to OpenC2 and vice versa. And I found that I got tired of making mistakes with the JSON. You forget a colon, or you forget a squiggly line, or a forward slash. And I would spend so many wasted minutes trying to figure that out, so I built a tool. This is the tool. So the tool allowed me to just, my 9-year-old can use this thing, where you just select boxes like a regular website. When you hit generate, it generates the JSON formatted OpenC2 command. But then, of course, I got greedy, like what else could I automate? So I added a code generator that creates executable, code. So I don't have to take the JSON and put it inside of a Python script. Why not just generate the entire Python with the JSON in it? And it kind of went crazy after that. And then I added curl and Node.js, curl, Python. And then I decided, hey, I want to share this. So got some help from Symantec Legal. And it's now available on GitHub under the Apache license. Let me show you the kind of the next slide. Yeah. So this is what I kept making mistakes on. Double ticks versus single ticks, colons. I'll miss a colon between the action and the query. So this is one of the examples out of my tool. So no more of those mistakes. And go to the next screenshot. And then this is what the tool ends up looking like. Right now, this is available. You just select the boxes, generate code. You can see the gray bar at the bottom is the one that doesn't work unless you know how to look at the source code and make it work. So that's a challenge, a little bounty for you. So there is a way to make the code execute against another open source tool that I developed to demonstrate OpenC2. Since I work at Symantec, I'm not able to, I shouldn't be endorsing a competitor, so a security competitor. So I went ahead and created a listener, an OpenC2 listener for someone we don't compete with, a Tesla Powerwall. So I OpenC2 enabled a Tesla Powerwall, and Symantec gave permission to publish that. And the beauty of how I coded that spaghetti code is that you can modify it to make it work with other things besides the Tesla Powerwall. So again, if you know how to hit F12 and do a little coding, you can modify it to do other stuff. But it saved me countless hours of time lost, to coding errors. It's available for free, Apache license, so you don't have to even contribute back, although please do. If you do something nice, return it to the community. That's it. It's so simple, but that was the beauty of it, and it works on PC and mobile.
Thank you. Okay, so I have a couple questions first, and then we'll open it up to the audience. So, Daniel, I was interested in a little bit more about the left of boom and just your input on how OpenC2 can support that idea.
Yep. I don't get to say left of boom often and have the audience know what I'm talking about, so that's nice.
Your mic, yeah.
And I'm worried I might want to use the mic. So thanks for the question on left of boom. So the goal with CS21, the long-term goal, is how can we address unknown threats, right? So we're trying to protect the power grid, and we don't want the power grid to go dark. And so how can we very quickly share remediations and share that? And what OpenC2 allows us to do is, in a very complex environment that has many different types of machines. You've got SEL, you've got GE, you've got Schneider, you've got a ABB, you've got a variety of environments, and so there's not necessarily a lot of consistency in even how those operate. Additionally, we have new technologies being implemented in there, newer switches, and so between Modbus, DMP3, common network traffic, and the command structure, being able to have a consistent open standard that you can consistently communicate with those in a time where you're trying to issue an order under stress, OpenC2, I think, is going to be allow, as it matures, allow that to happen. And so that's why, when we do our research on the use cases, we're looking at how we can leverage OpenC2 for that.
Good. Thank you. Okay, so this question, see if we can just go down the line. Start with you, Efrain. And you mentioned this a little bit in talking about publishing the code, but you couldn't do it for a competitor, so you were able to manipulate it to apply for Tesla. And with that challenge of what you're able to do, just being in a vendor, what are your thoughts on how we can help drive adoption of the standard? And I think I'll ask each of you that question, but what are some thoughts you have on how you can help, or what are some messages to folks in the room of what's necessary to help drive adoption of the standard?
Wow.
Hard question, sorry.
Yeah. I guess part of the reason I created this thing is to make it easier. Actually, I'm glad you left that slide up, because if you have folks in your organization that are challenged with connecting something together, today they might, buy something, or they'll try to find a tool online that does what they want it to do, and it'll require all kinds of drivers and all this extra software, or they can code it themselves, but that takes a lot of work. If you have those folks in your organization that are willing to take the challenge, this can at least bootstrap them pretty quickly. I mean, that's the whole idea. It's like, I want to test, can I control this thing? But I know how, I don't know, SQLite works, or I know how this Oracle works or whatever, but I don't know how to connect them with OpenC2. I would show them, I'm biased of course, but show them a tool like this, so and hopefully they'll improve it. But to get them started, I find the first roadblock is that, first step, like how do you even get started? And I thought that helped me, and I've heard from other folks that it's helping them, which is awesome. So providing tools that make it easier to connect. I could be wrong. You guys can tell me if this makes any sense, but I think these kind of tools help.
Okay, thanks.
Can I add to that real quick? I think that tools are a really important part of that. I think that what we are trying to do is get our customers to advocate to the vendors for it. I think it's really good that the vendors are getting involved early, but I think that their life becomes easier if customers are requesting this. And so we're trying to educate our customers, utilities. This helps make the environment safer. Ask the vendors to implement it. That'll help drive adoption as well.
Good. Okay, Phil, what's your perspective?
Yeah, I definitely agree with coming from the lowest level, which is Efrain says he's not a coder, but I've used his command generator. Works very well. Definitely is a programmer. So coming from below, coming from above, like meaning applying a little pressure to the vendors, I absolutely think that could work. And then also fitting into existing frameworks. So the product I use, Phantom, we already have a framework that has a lot of similarities to OpenC2. There are ways that this can fit directly into products that are already deployed in enterprise environments for our customers. So I think that would be another way forward to kind of accelerate things, so that it's not a sense that you're starting from scratch in any way. You're fitting into an existing system, and then it's just a additional plug-in to that system.
Good. Okay. And Mike, what are your ideas on that?
Yeah, I absolutely agree with everything. As a large company that uses probably every product on the market, we are well aware that every product has its own interface. And whenever we do, and we have a lot of in-house custom development, and we have to write adapters every single time. And I'm sure Phantom resonates with you, because you have to integrate with all these products. So I think just reinforcing again to all your vendors that this is a good thing to have a common interface. Certainly, as we're getting into a lot of virtualization and cloud, and things scale up and down, and you can plug and play, and having common interfaces certainly helps move that along.
I would even take it back to sort of early days of networking, right? So when networking language was fractured, and we had if you even remember Gopher or all these other different protocols, the network didn't really start accelerating until we hit HTTP and HTML, right? And so as we have all these different automation standards right now, if we can align ourselves to at least a common framework, it'll accelerate the ability to implement that automation and build stronger systems.
Okay, so we do have a panel of experts representing different aspects of industries, which hopefully connect to many of you in the room. So I do want to open this up to questions from the audience that you might want to ask about just utilization of OpenC2 or some of the questions you might have around automation. This is the audience participation part of the program.
I suddenly feel we were far too technical.
Yeah, the mic should be open.
Hi, thank you for interesting panel. And I'd like to know, OpenC2 is about to be standardized or kind of published. And I'd like to know if there's any kind of safe mechanism to extend it to include some of proprietary, maybe later standardized, but I would like to know there is some kind of a mechanism to do that.
So extendability, I get, and he's asking in the language? Yeah, so that's actually something that we're accounting for as we're building this out. So, certainly there's going to be use cases that companies have that don't apply, and the language is accounting for the way to be able to extend to support, use cases and special actuators you may have or special targets beyond what the language supports natively.
Yeah, you're a perfect candidate to review the first release.
Thank you.
All right, anybody else with questions?
One of the things that keeps me up at night is spoofing the sensors and spoofing the compute, especially with this broad scale adoption of things like convolutional neural nets and TensorFlow locally on mobile, and now we've got sort of smartphone guts that are ending up in IoT devices, and this hodgepodge and patchwork quilt of, protocols. Very, very difficult to test, very difficult to verify, and very difficult to forensically differentiate and parse real from fake once you've gone through the smoothing functions that make something palatable to a neural net of any kind, right? Particularly convolutional neural net. So is there yet some thought as to how to handle things at that local to next layer up assimilation, dealing with these things at different layers of localization, different layers of aggregation?
My answer may not be, I'm going to translate what you said into the way my brain's somewhat thinking, so hopefully I get close to this. So one of the challenges that I've always felt with IDS is that your adversary can buy the IDS and then train their systems to make it so they can pass something through that IDS so it won't be able to detect it, right? It's like AI, when deployed in the defense space, sort of creates a battle with itself. So an infinite loop where you have challenges there. I think when we start thinking, I'm very aware when we start realizing we're going to have a generic command structure, that also is something that the adversary could potentially use as well. So strong identity and trust has to be built into that framework. We have started addressing that in sticks. As far as OpenC2, I think OpenC still getting to the point of how do we build a common framework for sending commands. And but I'm hoping the work that we're doing there, and I think John Mark Gurney, who's here, has actually wrote an initial sort of paper and approach to that on how we can actually put identity around these messages.
So as a follow-on, data exhaust, tertiary data, tertiary metadata, data leakage, which even if I don't know the content, if I just feed that back into the system, I can spoof it, right? I can get it to learn the wrong thing. I can change the gradients. Any thoughts on sort of key encryption and sort of things like that?
I mean, I think that's,
I'm not asking you to give anything away. I'm just asking you.
Yeah, no. I think for me, it's not giving anything away. It's just using common concepts around cryptographic proof and proper signing and hash signing and cryptographic ledgers can help significantly there. But you have to be thorough as well, and you have to tie it to the machine. I think someone was talking about that earlier. So machine attestation is also very important.
Thank you.
So I'll take a different stab at it. So I'm going to oversimplify, but I often describe it, OpenC2, this way to my mother or whoever asks on the street. OpenC2 is like HTML. Okay, there are going to be different browser implementations that render it in different ways. So that's how I've been thinking about it. I might be totally off. I probably am. And of course, that's probably how it's going to be implemented too in practical world implementations, where you're going to have the mosaics. Well, actually, we're still waiting for the Netscape, right? We're waiting for that first, and then I did say that. But somebody's going to have to overlay the key infrastructure. Somebody's going to have to overlay. They're probably going to sign it. They're probably going to do all kinds of crazy stuff to it. But I think I consider OpenC2 the atomic, HTML. Let's see how people implement it. But it's going to be a beautiful thing, because like to what Daniel said, there was Gopher, Veronica, Archie, for those of you who were around for those days. But it didn't take off until the standard HTML came out. But it was ugly at first, and then a beautiful thing came from it.
The fact that we're going to have to guard against civil attacks.
Mm-hmm. Yep. Yep.
Okay, I think we
identified that this microphone has no Weber. I've just got back from China. Been working on next generation firewall stuff with Alibaba, Tencent. So what needs to be added to Open CS and the C2 kind of infrastructure to really support the use of AI tools? Because in that whole 80% world that we were talking about earlier of the automation, you really have the AI is going to be the big player. And in terms of being able to look at big data analytics of attack profiles, and then be able to direct appropriate actions. And not only that, but to be able to share it globally, right, between systems. So if an attack happens in New York, happens in London, how do we transfer that to Sydney, to Tokyo, and have that knowledge and that capability to respond?
So in my opinion, most of the things you talked about are out of scope for OpenC2, and that's okay. If the sense making and the decision making is done beforehand, as it should be, the OpenC2 command, unless I'm missing something, it really shouldn't have any need for artificial intelligence or machine learning. It should do what it's told to do, essentially. And also in response to the previous question, yes, machine learning and convolutional neural networks can be used adversarially as well against you, and so there is going to be somewhat of a cat and mouse game. But as far as the OpenC2 standard itself, I think this all happens kind of higher up in the stack than OpenC2, in my opinion.
So we just have to make sure that we think about the authentic. I can't figure out the word, but figure out the command has the authority to be issued.
Absolutely.
And I think you do still need to think about that in the framework.
So I'm Symantec, but I'm going to give some kudos to Phantom in that when you have a Phantom playbook with this spider web of connections to different products, because you're trying to integrate VirusTotal and Symantec and Trend and all this stuff, when you have a delete file and you have 5 branches because you have 5 different products, this is where OpenC2 would be awesome. Right? Now it's 1 branch.
So I've been doing a lot of work lately around ecosystems, and one of the interesting things to me as far as automation that I find isn't really covered a lot in industry is the impact it has on the feedback loop inside the typical threat response lifecycle. So, you know, typically when something gets to, actually tying it back to Sunil's earlier presentation around technology versus people, when something gets to the respond phase of the life cycle, it's typically very people-oriented, right? And then there's a feedback loop that occurs where the people then go to the technology providers and say, you know, this got through because you need to update this correlation rule, or you need to go and give, you know, this analytic needs more attention because it's not detecting these scenarios. So one of the things I've been wondering is, as we move down this path towards increased automation, the type of feedback actually changes. And I wonder if any thoughts, you know, I'm sure some thoughts have been, I'm wondering what your guys' perspective is around, you know, how in an increasingly automated world that feedback makes it back to the developers of the algorithms inside the enterprise that do these automated actions. Because it's almost like a different type of feedback needs to occur than is what occurring today.
Yeah, I absolutely agree. I was kind of alluding to that a little bit when I asked Sunil that question earlier, in that I think that there should be a content creation aspect of a lot of these different teams. And I think I see that enterprise where essentially a higher level feedback loop to those content creators so that they can modify the process going forward. Again, I don't think this is OpenC2. OpenC2. And I think that as you give content creators a very flexible tools and the ability to happen naturally within organizations.
Yeah, I agree. Link and just where you can observe the automation that occurred, you know, some detail around it. In cases where maybe the source was threat intelligence, using that, you know, sightings, observations to feedback in to kind of reinforce you know, that you're seeing those indicators on the network. But yeah, it's definitely a great question, and something as we mature, I'm sure will come out more.
Okay, we have our last question.
Hello, I'm David Bizel. I work in Sequoia, a French cybersecurity company. As panelists, you represent different populations, customers, service editors, product editors. How do you imagine the adoption of OpenC2 in the next years from the global security industry?
I'll take a stab. I'm imagining that the folks that have a lot of the same type of equipment will start to demand that we support the OpenC2. So anything where there's a lot of routers, switches, the same type of satellite, the same type of endpoint device, I don't know, thermostat providers, something that's very standardized, but is connected to by many other things. We need a few of those to first demand it. I think it's Joe that always says it has to be in the RFP. If you put, in your RFPs for the customer, they have to put, you have to support OpenC2 so that my job's easier. I'm pretending to be the customer, of course. These things to this one thing or that other thing.
I agree. I think the specific customers will tend to be those that have very environments. As you saw Sunil earlier from a large finance to regain some control points or policy points that they can actually enforce on. So that's probably where it's going to come.
Big guys.
I would just reiterate what you guys. It's need and pain makes you seek something else, and so doing something. So as things propagate and as people mature their start solving these advanced problems about automated remediation, I think that, you know, that use cases will come out and then we'll solve their problems there.
That initial spec being released, I mean, there's a lot of wonderful vendors helping, you know, get that out. Once there's something there that can be implemented, we can start, you know, requesting and, you know, if we're going to use our products.
Yeah, but I'd just like to add to that there is a cost in the way I sell it. There's a cost savings aspect to this, right? I think people are chomping on the bit to get that final release. And then especially when you have to develop, you know, these two applications are going to speak French. These are going to speak Esperanto. These are going to speak Latin. These are going to speak Japanese. Why can't we just, you know, have, okay, I think that's how I try to sell it too, is that you have this JSON file that shows exactly what's going to happen, and it's readable. It's not in binary or some crazy legal.
Great, thank you. And then just any final thoughts from the panel as you've got the mic that you can just one last push on how great this is?
Thanks for having us here. It's been a great discussion.
I would just add, same thing I said yesterday at another panel. If you have folks in your organizations that want to play in this space, they want to develop code, break the barriers for them. You know, talk to legal, especially, you know, young folks first starting out. They don't know what they can and can't do, keep them out of trouble. But let them, yeah, they just published a GitHub, right? Try to open up the doors for them and let them participate. And I think some beautiful things will come from that.
Public reviews coming up. Please take a look. Eyeballs build stronger things.
Yeah, and you know, you can start a pilot if you're not doing any looking at automation today. You can start a pilot. I'm sure you probably have some high confidence, low risk scenarios that you can do open loop. So you can just automate some of those manual methods and procedures you have today using some of the tools out there. And you know, get involved OpenC2, look at IACD. There's a lot of good work going on.
Okay. Thank you all for your time and discussion today, and more importantly, for your participation in the standards themselves and helping it get to the point that it is about to be published for review. So very much appreciated. Thank you. Okay, so now we do have a break for lunch until 1:30, and according to the agenda, I didn't get the note about what I was supposed to say for lunch, but it says it's located on the main level in the L rooms. That's what they said in the beginning. So lunch until 1:30, and a reminder that the slides that are used will be posted on the webpage after the conference, along with links to the recorded content. So that will be after the conference is over. It'll be on the main page of the website. Thank you, guys.
Thank you. Just a very quick